Hello, everyone. Thank you for joining the Pure Air Filtration webinar today. Today's topic will be electronic monitoring devices, what they are, how they work, and how they will benefit you. Hosted by myself, David Marsau. I'm an electronics program manager with Pure Air Filtration. Started here earlier this year and really excited to walk you through our electronic devices this morning. So we'll go ahead and start with our table of contents. We'll do a brief introduction to Pure Air Filtration, go over the electronics laboratory. It's a new lab in our office. The bulk of our conversation will be about the Pure Air electronic monitoring devices, the LifeGuard Media Bed Monitor, and the electronic Corrosivity monitor, and then a brief summary at the end. So, a brief introduction to Pure Filtration. It's a manufacturing facility in Atlanta, Georgia. It's been women-owned and operated since 2023. It was established 21 years ago by Kevin Jamison. It's now since grown to a little more than over 60 employees, seen a lot of growth in the last couple years. It's very exciting. And now we've also done sales to over 60 countries around the world. Another thing that's really exciting, I believe this happened last year, maybe the year prior, is our ISO 9001 certification. And our team's really proud of that. It's opened a lot of opportunities for us. So now we'll go over a part that I am very excited about, is the electronics laboratory. This is a lab that was built last year, really upgraded this year, but Pure Filtration moved into a new building middle of last year, and that allowed us to have a dedicated space for electronics. It's where the assembly, programming, refinement of all of our Pure monitoring devices is conducted. It's built in-house to maintain full control over quality and performance. It's allowed us to expand our team and assembly, adding a couple headcount, and also increase our production capacity, which is important because we've put out a lot of units this year. Assembled by the Pure Electronics team with specialized tools and testing to make sure our quality is up to par, and specialized tools to make sure our team is efficient when they produce. It features an air shower as well to make sure that we are operating in a dust-free environment to protect our sensitive components. Want to make sure that everything we deliver to our clients is in top quality before we send it out the door. An important thing also is that we have electrostatic discharge protection to ensure all of our internal components are not damaged. A lot of as you can see in that picture in the top right, the green tops to a lot of our tables are ESD resistant. For our team, when they're working on some of our electronics devices or sensors, it's really important to make sure there's no ESD discharges to our components before they're sent out the door. So that's been a big plus for our team to have in their office. Maintains a clean, controlled conditions to ensure reliability, and supports continued innovation of systems like LifeGuard and our ECN V2. Having a lab like this is going to allow us to further innovate and really build on to our products and add more features to our products in the near future. So it's very exciting. All right. So we're going to get into the bulk of our conversation today, which is the electronic monitoring devices. The two devices we're going to go over today are the LifeGuard Media Bed Monitor and the Environmental Corrosivity Monitor, the ECM-V2 as it's commonly called. These were designed to elevate our customers' air quality and provide real-time insights to our customers. They're state-of-the-art electronics assembled in-house, the LifeGuard being proprietary to Pure Air Filtration. They're used across multiple industries, such as municipal odor control, toxic gas removal for industrial facilities, and some energy sectors as well. We'll go into more detail further in this presentation. Exceptional benefit for users as well when it comes to cost savings, visibility, and compliance as well. So we'll start off going in depth on the LifeGuard Media Bed Monitor. This is truly the industry's first and only real-time media bed monitor that takes filtration management to new heights. It can be applied to multiple systems that PureAir currently develops, including our packed bed system or PBS, our V-bank transition system, industrial vertical bed system or other VBSs, our side access housing unit, and then also the emergency gas scrubber. And some of these units obviously scrub different gases, right? We have hydrogen sulfide scrubbing, volatile organic chemicals or VOCs, ammonia, and also chlorine gas. So the LifeGuard is able to be fitted on all of these different units for gas detection and media consumption detection on all those separate systems. A quick overview on the history of the LifeGuard bed monitor. So it started in 2014, at least the first iteration of our media bed monitor did. And that was when the first install happened. It was, as you can see here in the bottom left, simply a metal rod with sensors along it that would be into the media bed going into a control panel. As new designs came out and were recently developed over the years, the EBM-E is a similar design to the first version, just a smaller control box or control panel. The EBM V2 looks a lot more like our systems today. You have the smaller controller with our sensor housings that would be inserted into using tubing into the actual systems and beds. And then today we have our LifeGuard Media Bed Monitor, also a much catchier name, so we can thank marketing for that. But our LifeGuard Media Bed Monitor with the smaller sensor housing that it's the current configuration today. And as you can see as well at the top right, we have three separate patents for this device going back to November of 2018 all the way through 2025 this year, which we patented the latest version of the LifeGuard. So very exciting for us to complete that process. How it works. So the LifeGuard has a programmable logic controller, or just controller is what we call it. It's able to take measurements from a set of externally mounted sensors with a plus minus 0.5% accuracy. The system analyzes these measurements to detect changes and calculate remaining media life. So this device is really the brain of the operations for our LifeGuard. It has the ability to have different firmwares downloaded onto it, depending on what type of gas is being filtered and what kind of device is scrubbing that gas. So let's say for hydrogen sulfide, right, you're going to have a lot of different vertical beds or side access housing. It's going to be a different firmware than, let's say, an EGS or emergency gas scrubber, which scrubs chlorine. The chlorine scrubbers generally come on in emergency situations to scrub chlorine gas from an industrial setting. So it would need to be different, right, from the hydrogen sulfide that's usually in our scrubber, that's usually in our municipal odor control businesses or municipalities. So it's important to have different logic in these controllers for different situations. Um, it's able to also do wired results transmission via 4 to 20 milliamp and an alarm relay contact. So the 4 to 20 milliamp can integrate into any SCADA system that our client wants to use if they're not able to use the cloud web portal for wireless results. Also, they can use an alarm relay contact. And how that contact operates is it stays open pretty much the entire time, but the general consensus is that when it hits around the 60-day mark, when it reduces down to about 60 days, what we call the media refresh time, that's when the alarm relay contact will close, essentially alerting our client, hey, you need to reach out and potentially look at getting new media for your system to make sure there's no breakthroughs and that you stay compliant. That media refresh time can be adjusted depending on the client's recommendation or engineering recommendations, but generally we keep it around 60 days. So for a couple configurations of our sensors, specifically hydrogen sulfide, we use what we call a microelectromechanical systems or MEMS sensors. These sensors are really fascinating in that they use tiny mechanical elements with electronics on a microchip. They're made up of both electronic and mechanical components. They read and process data, while the mechanical side reacts to physical changes in the environment. These can measure physical qualities like magnetic fields, pressure, temperature, gases in our situation, depending on the configuration. These gas sensors use a chemical reaction that alters electrical properties. That's essentially how our device works, right? The MEMS sensor will detect a change in gas concentration and it correlates to a voltage reading in our device, which allows us to see if you're having increased volumes of gas into the system through our media beds. As gas concentration increases, like I said, voltage changes, providing a measurable correlated signal, and it allows for precise monitoring. Some other benefits of using a MEMS sensor are the compact size, the low power consumption, fast response time, and the digital analog output options. Benefits and advantages of using the LifeGuard: maximizing the media lifespan is a critical one, right? Replace media only when necessary, reducing costs and extending system performance. We've seen some systems, right, where the engineering recommendations we receive on the front end, where we expect a certain volume of gas to go into a system, may alter over the lifespan of that system. So this device allows you to really be proactive in the visibility of how that media is being consumed based on the volume of gas it's seeing. Improved system reliability, early detection of media saturations prevents odor leaks and system failures. The predictable maintenance, right? Planning maintenance proactively, avoiding costly emergencies and staying on budget. So really the financial planning aspect of it. This will allow you to get a head start on making sure you're financially ready to buy media or make sure your system is operating as intended as it's running through media. Cost savings and efficiency, again, continuous monitoring helps reduce the maintenance costs and operational downtime. Another neat thing about the LifeGuard as well is the seamless retrofitting on existing systems. I've been able to do a couple retrofits myself, but it can be equipped with a LifeGuard within a couple hours, not days. It usually really only does take a couple hours. We can put a LifeGuard into a media bed on PureAir systems or non-PureAir systems to detect media consumption. When is it necessary? Odor control is a huge necessity for the LifeGuard, right? It really does prevent odorous gas breakthrough. It stops complaints from employees, surrounding neighbors before they begin. Proactive maintenance planning for annual budgets. The LifeGuard is a huge component in this, right? And just measuring the overall media consumption. It can keep compliant for a lot of our municipalities that, will not have neighborhoods having odor going into them and can reduce the chance of being fined by those cities or municipalities. Toxic gas control, mainly in our industrial sectors, ensuring optimal performance to protect life in critical situations, provides peace of mind and can track media usage over time to detect small chlorine gas traces. Protecting electronics and corrosive gas management, preventive corrosive gas breakthrough, saving money to avoid costly equipment repairs, reduce risk of corrosion causing downtime, leading to significant loss in production and revenue. And then indoor air quality. Ensures air quality remains at the purest level, protects people, artifacts, artwork, and more by changing media before gas breakthrough. So really all of these benefits to our clients, depending on what their needs are, the LifeGuard can play a huge role in that. When it comes to cost saving, proactivity, making sure there's no breakthroughs, staying compliant, and financial planning for changing out media in the future. So here's a brief example from a wastewater treatment plant located in Ventura, California. The initial projected changeout date was in June of 2026, and the install date was around 2022, late 2022 to 2023. So as you can see, the overall volume of gas that was seen in this system, I think was above what was initially intended or what was thought when the system was installed. So you can see how the chart flows down to the right and goes all the way to October of 2024. So realistically, the projected changeout date dropped all the way down to around February. It looks like February to March of 2025 due to the date of the readings taken and the projected changeout date. So the media was being consumed at a faster rate than what was initially anticipated, and that allowed our client to take more proactive action to order media and make sure there was no odor breakthrough and they were compliant. So this is a graph from the same water treatment plant in Ventura, California. So the number of days remaining, it can show you the date of the reading as well, but it just shows the overall reduction in days remaining as the readings were taking place over its lifespan. So from October of 2022 all the way to October of 2024, you can see how the media was being consumed at a pretty steady rate all the way down to 2024, even though the initial changeout date was 2026. So that wraps it up for the LifeGuard media bed monitor. Right, we'll go into now our next electronic device, which is the environmental corrosivity monitor, the ECM V2. So what does the ECM V2 do? So it continuously detects and measures corrosion in real time. So it provides copper corrosion readings, silver corrosion reading, temperature reading, a differential room pressure reading, and a humidity reading. All of this data is logged on a SD card. It can be transmitted via Modbus, Wi-Fi, or 4 to 20 milliamp output. How it works. So the ECM V2 provides live copper and silver ISA ratings, which is the um, industry standard for automation, I believe, rating by using one of a copper and silver sensor. The LCD display shows corrosion levels and rate for each channel. These sensors use and the devices use what was called a quartz crystal microbalance technology. And essentially what that is it's a frequency that's going through a silver or copper coupon, right? The frequency, the vibration is essentially vibrating the coupon at a certain frequency. And as gas molecules attach to the coupon, that frequency changes. And when you correlate that with a time scale, essentially, you can tell the rate of corrosion by these gas molecules attaching to the silver coupon or the copper coupon. So that allows us to, in turn, apply an ISA standard corrosion rating of the room via G1 through GX. G1 being mild, acceptable, G2 moderate, slightly corrosive, G3 harsh and concerning, GX severe. These can operate independently or feed real-time data to a central database. The alerts are triggered if conditions fall outside of set parameter. The device will let you know. There's a light on it that'll trigger red and say, hey, this room is GX or G3. Some action needs to be taken to fix that issue. Additionally, the device can read temperature, humidity, and pressure. The ideal range in control rooms essentially are 68 to 72 degrees. If it reaches 80, it's often a sign the air handler is malfunctioning and triggering an investigation. A 10% relative humidity rise increases corrosion by one severity level. Many facilities set alerts at 55% relative humidity, aiming to stay near around 45%. It can increases can often signal dehumidifier issues. Pressure as well. So if scrubbers shut off, pressures can drop to zero, setting off alarms and prompting corrective action. A lot of control rooms generally want to maintain a positive pressure environment with that humidity staying around 45 and temperature stable between 68 and 72. The positive pressure is really important, which allows the air to be essentially pushed out of the room, right? If it's not in positive pressure, corrosive gases can infiltrate the wall, the ceiling, any cracks or crevices in the room, and will infiltrate the room and cause corrosion potentially to critical controls and electronics in multiple industries. Some of the benefits of the ECM V2 protects equipment, extends its lifespan, and anticipates costly downtime events. Um, it does constant environment surveillance, early corrosion detection. It's very easy to install. It can really just be drilled into the side of a panel or on a wall as long as it has a PoE or power plugged up into it. A long service life. The device can last a long time, really. If there is corrosive gases, the sensors are really the only thing that needs to be changed if they are detecting a G3 or GX environment. Connects to varied systems for data capture. the SD card for data storage, and as well 24/7 Sentry for unpopulated electrical rooms. So places that maybe people don't visit a lot, right? This device can make sure it's being monitored at all times. The ECM V2 serves a lot of high-stake industries where air quality is critical. Data centers and control rooms, which we're seeing a rise in, obviously, especially with AI building more data centers in a lot of our big municipalities and cities. It's going to become more and more critical. Oil and gas refineries and motor control centers, manufacturing facilities and process plants, pulp and paper mills. A lot of these industries cannot afford to have downtime. They're constantly running 24/7, 7 days a week, and that really this device can stop a lot of potential downtime and save a lot of money in that process, right? I know there are some facilities where if they're down for more than a couple days, it's millions of dollars of lost revenue and millions of dollars of cost. So this simple device can really, alert a lot of our clients or end users to potential warning signs or issues that are happening in their control rooms and critical areas in their plants. An example of that being a large paper mill in Georgia installed many of our ECMV2s in their most critical rooms. I had a chance to visit this site. They received a lot of damaging corrosive air present in their rooms. The ECMV2 was able to pick up on that. It notified our client that they were seeing G3 or GX gases rather quickly in some of these rooms. They called PureAir for assistance. A solution was provided to maintain optimal air quality, keeping the corrosive gases away from important electronics. Had it gone unnoticed, the mill could have faced equipment failure, causing downtime for weeks, potentially months, and extreme loss of revenue into the millions potentially. When they gave us a call, our field service team, which is a wonderful team, was able to provide room sealing. We were able to provide them new sensors for the ECMV2. So once the room was sealed and it was a positive pressure, air scrubbed environment with our ECMs in there as well, there was constant protection from these corrosive gases, and they could sleep at night, right, and have peace of mind that there was not going to be potential loss of revenue or downtime for some of their really expensive control systems and electronics in that mill. So in summary, this is a really exciting time at PureAir Filtration, especially in electronics. It's a growing sector. We're putting a lot of these products on our main air scrubbing systems. We're continuing to do research and development for PureAir electronics to provide customers with our latest technology for both the LifeGuard and the ECM V2. We have some really exciting developments that we're working on. Hopefully we can share more about that in the next 6 months to a year. But our team is working really hard to make sure, we're staying on the innovative cutting edge and that we're not being complacent and making sure that, our customers have the best quality and best systems and electronics that we can provide them moving forward. Uh, we also, with some of these systems being so new, gathering feedback from our customers and clients is critically important, right? So as we rolled out the LifeGuard, really the newest iteration of the LifeGuard early last year, being able to gather feedback from our customers and clients is going to allow us to really work on the roadmap for future innovation for these products and build more features that they would like to see moving forward. Another thing we're working on as well is adding a biogas sensor. It's in development right now for the LifeGuard, which for those who know, biogas is an extremely harsh environment with high volumes of hydrogen sulfide. So that's something we're currently working towards, and I'm happy to share that. But we're currently in development working with Kevin Jamison, our CEO, and our electronics team to make sure we can provide a sensor that can withstand such a harsh environment, but also provide the same level of quality our clients expect. All right, that wraps it up today. I would love to answer any questions anyone has. Um, it's been a joy sharing more information about our electronics department with you all today.